So I just write down the point. Each node in a binary tree have maximum 2 childs. So it contains maximum 2 childs. So this is a binary tree node with no childs, and this is also a binary tree in which this node 1 have 2 childs. This is also a binary tree, and a node with the 3 childs cannot be a binary tree. Okay, so the main property is every node have maximum 2 childs. Okay, so let's draw a simple binary tree. Suppose here 2 and 3, and here is 4 and 5, and here is 6 and 7, and then suppose this level have 8, 9, 10, 11, 13, 14, 15 and 16. Okay, suppose these are the nodes. So in binary tree, so if I consider this one as label 1, this is as label 2, this is as label 3, and this one is as label 4, then the height of the tree would be, so if you need to define the height of a tree, then I can say that the height of tree is number of levels minus 1. This is the first definition. The height of the tree is number of levels minus 1. Second is, if you want to count the number of nodes at each level, so let me draw here. At level 1, the number of nodes are 1. So this level contain only one node. At level 2, the number of nodes are 2. So this will contain 2 nodes. At level 3, we have 4 nodes. At level 4, we have 1, 2, 3, 4, 5, 6, 7, 8 nodes. Okay, so I can say that at level this one, it is a level 1. It means you can say that it contain 2 to the power 1 minus 1. If level 1 is there, it means 2 to the power 0, or we can say that one node is there. At level 2, we can have 2 to the power 2 minus 1, or 2 to the power 1, or 2 nodes are there. At level 3, we have 2 to the power 3 minus 1, or 2 to the power 2, or we can say that 4 nodes are there. At level 4, we have 2 to the power 4 minus 1, or 2 to the power 3, or we can say that 8 levels are there, 8 nodes are there. Okay, so if we want to calculate the number of nodes at every level in a binary tree, then it would be 2 to the power L minus 1, where L is the level at which we want to find out the number of nodes, and it is the maximum number of nodes. So I can say that it is a maximum number of nodes that a level can have. Okay, so the maximum number of nodes can be given as, at each level can be given as 2 to the power L minus 1, where L is a level number. Okay, now if you want to calculate the total number of nodes in a tree, so you can find out the total number of nodes also. So the total number of nodes in level L binary tree, then it is nothing but 2 to the power L minus 1. Okay, so the total number of node is this. Or how we find out this one? This is nothing but I just sum up the uh, all nodes at each level. So if there are 1 to L levels, then it is nothing but sum up of 2 to the power L minus I minus 1. Okay, so where I goes to 1 to L. If L levels are there, we just sum up all the nodes in the binary tree. So this would result in this expression 2 to the power L minus 1. So if you want to find out the number of nodes in a given binary tree of level L, then you can say that it is nothing but 2 to the power L minus 1. So we have total number of these nodes. Maximum we can have maximum these many of nodes. So we are talking about the upper bound, the maximum number of nodes in at each level, and the maximum number of nodes that a binary tree can have. Okay, so this is all about the binary tree properties. Now next is what is complete binary tree. So I just rough it out. So next is complete binary tree. Now complete binary tree is a binary tree where so I just draw it, the complete binary tree. Suppose we have these nodes 10, 20, 30, 40, 50, 1, 2, 3. Though these nodes are given. So to make a complete binary tree, what we need to do? We just pick a node and make it as a root. Then pick the another node. So here insert in the left. So if left is empty, then insert the node in the left. So we just insert it in the left to right, top to bottom manner. So top to bottom, left to right. After 30, I will insert here. Then because top to bottom, left to right, 40 will be inserted here. 50 will be inserted here. Then we have 1, then we have 2, and 3 will be inserted here. So complete binary tree is nothing but we have to insert the node in top to bottom and in the left to right manner. Okay, so this type of tree are complete binary tree. So a binary tree is said to be complete if it is satisfy the following conditions. So a tree is complete if it satisfy the two condition. One is at every node after left is over then only go to right. So when left is over, then only go to right portion of the tree. So if this is a node, it is a complete binary tree. Yes. Now tell me, this is not a complete binary tree because here we have a space for the left and we insert the node at the right. So it is not a complete binary tree. Now this one is a complete binary tree. Yes, because we insert it in the left first, and again this node is also a complete binary tree because we insert 2 first, then 3. So this is a complete binary tree. So it is a first property. Now second property is A second property of a complete binary tree is after one level is over, or we can say that after one level is filled, then only go to the next level. Okay, so for example, this one is a complete binary tree, this one is also a complete binary tree. If I insert like this is not a complete binary tree because this level is not over yet and we go to the next level, so this is not a complete binary tree. Similarly, if I draw a tree like 1, insert 2 here, insert 3 here, and insert 4 here. Now level is over, it is fine, we insert the 4 in the next level, but in the next level we have to insert at the left hand side, so it is not a complete binary tree. Similarly, if a tree is given like 1, 2, 3 and 4, if 4 is inserted here, then yes, it is a complete binary tree. Okay, so a tree to be complete binary tree, what it requires that every node is inserted from left to right and top to bottom manner. So at every node after left is over, we have to insert or we have to go to the right part. If it is empty, we have to insert at the right. If the right part is also filled, then we go to the next level, and in the next level we search for the left part. If it is empty, then we insert the information at the left part and then go to the right. So this is about the complete binary tree. Now in complete binary tree there are some corollaries. The first corollary is, for a complete binary tree, if n nodes are there in complete binary trees, then we have always log n base 2 levels. So for n node complete binary tree, always we have log n base 2 levels, and the minimum number of nodes at each level can be given as 2 to the power, so at each level, so if a level number is L, then it can be given as 2 to the power L minus 1 number of nodes. Okay, so the minimum number of nodes at each level in complete binary tree is 2 to the power L minus 1. Okay, so this is a complete binary tree. Now another thing is, after complete binary tree we need to study about the fully complete binary tree. So there is a little bit difference between a complete binary tree and a fully complete binary tree. So I just explain you what is the difference. So for a tree to be a fully complete binary tree, so it is nothing but, just see the example which tree is not a fully complete binary tree. If a tree given is as this, we have these nodes and we so one tree is given like this, and another tree is given with this. So this is called a fully complete binary tree, in which at each level we have filled all the information and there is no right or left part empty except the leaf nodes. Okay, so at a fully complete binary tree means the last level is filled completely, that last level of the tree filled completely. So if the last level of tree or a complete binary tree is filled completely, then we can say that it is a fully complete binary tree. Okay, so this is about the binary trees, and now in next lecture we will focus on the heap trees, or what is heap. Okay, thank you.